Good morning all. We'll be seeing today the concept of class and object and some very basic and most important fundamental properties in object oriented programming. Right, we begin with our first very simple concept. Now what I see in front of me is a ice tray and I see here ice cubes. What we actually consume is the ice cubes. We consume the ice cubes and again fill in water into the ice tray and keep it for freezing. Once again we get a new set of ice cubes which we keep on consuming. So we are not bothered about the ice tray actually, and this is not what we ever consuming, but then this is useful to make such kind of ice cubes which we consume. So this real life example can be correlated with what we are seeing in object oriented programming like this. In object oriented programming, anything which helps me to make objects is called a class, and using the class when I am able to make something, it's called as an object. So let's look at some very basic definition. Class is a template which is used for making objects, and an object is a copy of the template. We move further. I see some real life pictures, a house, a bus and a toaster. All of them would definitely have some characteristics or some properties or some attributes. Let's have a look. Now, each entity is having some attributes. The house is having attributes like number of windows. The door underscore locked variable indicates whether the door is locked or not. A carpet area, the pin code which means the address of the house. A bus would have some attributes like number of seats, number of tires, an engine capacity, a license number, and something similar to these could be the properties of a toaster. Looking further, we also understand that if I have to enter the house or leave from the house, I need to open the door. If I have to post some letters to this house, I need the address of this house. If I want to move this bus, I will drive a bus. If I would toast some bread, I would toast. That means my action is going to be toast or toasting. So every entity in real life has some methods by which we can use the entity or use the attributes of the entity, and these are called as methods in object oriented programming also. So we conclude our definition for a class. A class is defined as a collection of attributes which you see here and methods which you see here. The get address method is going to get me the pin code of the house, and is logged method is going to find whether the door of the house is logged or not. And these methods which operate on those attributes, so it's very clear that the get address method of the house will not find the number of seats in a bus. So the methods of a class always operate on its own properties or attributes. We move further. Let's have a look at this. I assume that the audience sitting in front of me are aware about the C programming language. Remember, C and PHP are mother of all programming languages. They are the first languages which we should actually learn before learning anything else. Back to our class syntax. A class is very similar to a struct in C. Let's have a look at this definition. I saw a house in the previous slide. If I define it in Java, it will look something like this. I have this black part indicating to me four attributes: number of windows, door locked, carpet area, and pin code. Void get address is the first method, and boolean is locked is the next method. The get address method simply prints the value of the pin code, and is logged method finds the value of the integer door underscore logged, which could be 0 or not 0. In case if it is 0, I would print at the output that door is open, please lock it. Now people would be wondering, the system.out.println, what is it? System.out.println is same as printf in our old and gold C language. The plus operator which I have used in this statement means concat. I am concating pin code equal to the value of the pin code which is stored in this variable. So just recall, this first part is the attributes or properties. Put along with the attributes or properties are the two methods which are working on these attributes. Always remember, this word class can't be changed by us. We can't make it as classes. Class means a class. In Java, class is a keyword. System.out.println means printf, and in the println statement, whenever we use the plus sign, it means concat. We move further. Again, coming back to the same diagram, the ice tray and the ice cubes. Let's have a look at this. An object is defined as an instance of a class. This is a formal definition of an object in Java. Now, how do we make it? Now, how do we make an object in Java? To make an object in Java, we follow two steps. First, declaration. Second, instantiation. In declaration, we write the name of the class, say house, and h, where h is a variable of type house. When you write house h, I have declared a variable h of type house, but this variable does not consume any space. Surprising. In C, on declaration, a variable is occupying some certain space. The same thing does not happen in Java. Java just declares an object and only books space after you instantiate it. Let's have a look at the instantiation. An instantiation looks something like this. H is equal to new house. Here, new key is a keyword which means book space required to store the attributes of the class house. The class house has 4 integers. I hope we all recall. If each integer takes 4 bytes of space, 4 integers should take 16 bytes of space in the computer's memory. So, we conclude that to make an object in Java, we require two steps. First, declaration, and second is instantiation. We look further. There are 4 very important properties. These are in fact the most fundamental properties which each individual should know to study anything in object-oriented programming. Inheritance, polymorphism, encapsulation, abstraction. These are the formal definitions for each term. Please take a minute and scan each one of them in simple sense. When I derive some properties from my parent, I am said to be inheriting my parent. When I behave differently in different situations, I am seeing or exhibiting a property called polymorphism. When I put data and methods together in a class, I am showing a property called encapsulation. And lastly, when I am using the data in a class only via the methods of the class, I am showing a property called abstraction. Please don't worry, they seem confusing, but we are going to see examples for each. Moving further. Right, now I see a vehicle over here. Well, this doesn't look like a sports car. This is a vehicle which is having some properties. Now look at this. This seems to be a sports car. Now what could be the difference between this car and the sports car? The car has some properties like number of doors, number of tires, the color, the engine capacity. But a sports car also has all those properties. Apart from that, it has a specialized property which signifies it to be a sports car, and that's its speed. Have a look. A vehicle has these four basic properties. These four basic properties are also applicable to a sports car, but it has one more called highest speed. So when I make a class called sports car, instead of defining all the four properties of a vehicle class plus one of its own, that is five properties, it would be quick work to define just one property called highest speed and derive the four properties from the class called vehicle data. And this concept of a child class deriving properties from the parent is called inheritance. We look further. Have a look at this. I've got three figures here: a batsman, a computer operator, and a Santa Claus. I give you 30 seconds. What do you think is common among them? That's right. All of these are people like you and me, and they would definitely have something like name, age, gender, their profession, some weight, some height. All of them have some certain common properties. Why don't we take all that common properties, put it together in a class called person? This brings the logical sense of why we should have inheritance. We first define a class which is generic, which is called the parent class or the super class, and then we define classes inheriting from person. So all the common properties of a person come to them, and we put only the specific or special properties in them, which could be batting average for a batsman, softwares which this computer operator knows, and number of gifts which Santa Claus is having. We move further. I see the same lady here. The lady in the first case is performing as a doctor, and in the second case he's performing a role of a player in a golf court. Uh, if I analyze it in a technical way, I see that the same lady is behaving differently at different points of time, the way you and I do. Like, for example, the audience sitting in front of me could be son and daughter to somebody at home, but right now they're audiences or students to me. Let's look at this example in terms of Java programming. I have got three methods: area with two parameters or two integers, the second method area with one parameter, that is a float, and a third parameter area with again one parameter, that is an integer. Over here, the method area, when called and you pass two parameters to it, I would expect to calculate the area of a rectangle. When I call the area, which is the second method, and pass only one variable called float radius, I am going to calculate the area of a circle. And in the last case, it is quite expected you're going to calculate the area of a square. That means the same method area behaves differently because you are passing it either a different number of parameters or different type of parameters. This concept is called as polymorphism. And yes, it is also called as method overloading as regards to Java, because this is the same method called area and you're overloading it because the names of all the methods are the same, but they behave differently when you pass different parameters to it. We look further. Encapsulation is a very simple concept which says if you put the data and all the methods together in a single class, then you are encapsulating them. In other words, encapsulation means between the brace brackets I have data and methods put together. We move further. Very closely related to encapsulation is a concept called abstraction. Now please notice, I can use the data x and y of this class point in two ways. Have a look at this example. We can access data of point class in two ways. In the first way, I am openly accessing x and y by using the object p as p dot x and assigning some value 10 to it, and p dot y assigning some value 10 to it once again. In the second case, I am again accessing x and y, but in a decent way via its methods. It's a bad practice to access data openly like this outside the class. It's a correct practice to access the data of a class only via its methods. Now I know you're going to think why. There are some advantages which we will be seeing in the due course of time. For the time being, let's accept that if you access the data of a class only via its methods, you are ensuring the property of abstraction. We look further. Let's have a recap. हमने चार properties को view किया है. First, inheritance. Second, polymorphism. Third, encapsulation. And the fourth is abstraction. Let's recall its definitions quickly in 30 seconds. Yes, that's right. All of you, that's right. Inheritance means deriving properties from a parent. Polymorphism means behaving differently in different situations. Encapsulation means putting data and methods together. And abstraction means accessing the data only via the methods. You all are correct. Thank you very much. If you have any queries or a feedback about this session, you can always contact me. Before I conclude, we'll be seeing in some time from now, encapsulation and abstraction are also called as information hiding. And that's my ID, Rocky @swenconsultants.com, and this is what I teach. Please do visit the link tpo.swenconsultants.com for more information about your career related courses, and that's me. Thank you.